This is a discussion on the periodic table. The periodic table is one of these documents, the resource that we get to use basically every day in chemistry. There's never going to be a time on a test or on a content quiz where I say, hey, you can't use your periodic. We won't get to use them on our ions or element quizzes, but for the rest of everything we do in class, you'll be able to use this resource. So we want to get really familiar with the resource and also learn some of the kind of hidden facts that you can find inside of the table that's not explicitly told to you. What it basically is just the arrangement of all the elements that we know about, and if there's some synthetic elements that haven't been identified yet, we can predict where those elements would fall on the periodic table based on how it's arranged, and that's because it's arranged based on increasing atomic number, the number of protons of each atom going from left to right across the periodic table, and then the squares that are stacked on top of each other vertically are arranged by similar properties. And then we can talk about horizontal arrangements and vertical arrangements, and we have different names, synonyms of each other that mean the horizontal and then mean the vertical. So that's what we're going to talk about next. So horizontal versus vertical. The horizontal arrangement, rows, series, periods, those are synonyms that all mean the exact same thing, going left to right. And those atoms are arranged by increasing atomic number. Now, when the periodic table was originally put together, some of the first tries were to put the table together by increasing atomic mass, but then Dmitry Mendeleev figured out that the atoms should be placed based on increasing an atomic number. That made more sense based on how the properties would line up, and then that's why the properties line up vertically. Going left to right, the names that we can use would be series, a row, or a period. Series, row, or period. So that's left to right arrangements, the horizontal arrangements of the atoms. Going top to bottom vertically would be columns, families, or groups. Now, on an old building, or if you think of Italian buildings like in Rome, many of those buildings had columns, and the columns are vertically arranged. They hold up the roof of the building, so you can think columns are vertical. That might be a mnemonic that will help you. Also, for family, the reason why it's called family is because the atoms that are in a vertical arrangement have similar properties, much like you might have similar characteristics to your family members. Maybe you have the same color of eyes or the same color of hair, etc. So that's the horizontal and vertical arrangements. We have horizontal, row, series, period. Vertical would be column, family, group. Those are 6 words that you should be familiar with. Then the periodic table can be grouped into 3 large clusters of atoms. The 2 larger ones are metals and nonmetals, and we have some properties that are characteristic of both of those types of elements. So metals we're going to find are on the left-hand side of the stair-step line, so let me just show you where that is. The stair-step line on your periodic is found right here. So metals are found on the left-hand side, and to keep track of that, it does say metals on the top. So everything that's over here, except for hydrogen, is a metal. We'll talk about why hydrogen's over on the left-hand side later on. It is the first atom, has 1 proton, so that's why it's there, but also there's some properties of electrons that we're going to talk about. So metals are on the left-hand side, and then they have some characteristic properties. Now, doesn't mean that all metals show these properties to the same degree, but in general, these are some trends that we can see. Metals are good conductors of heat and electricity. You can think about pans. Most pans that you put on your stove are going to be made out of metal. Or wiring inside of buildings will be made out of metal because they can conduct, they can transmit heat, they can transmit electricity. They're lustrous, which also means shiny. Like think about jewelry. Most jewelry has at least some components that are metal to add that shine. Malleable means that they can be hammered, like a mallet, malleable. Mallet is another name for a hammer. And then ductile, they can be pulled into thin wires. And I like to think of heating ducts in the basement of your house or somewhere in your house. You might have seen heating ducts. They're long and thin, just like a wire would be, so ductile, pulled into wires. High tensile strength, if you think about cable cars, if you've ever gone skiing, that cable is very strong, and that's a representation of tensile strength. And then most of the metals are room temperature solids. So at room temperature, which is about 22 degrees C or 70 Fahrenheit, these are going to be solid state of matter. An example of that would be some copper. I can show you a piece of copper. You can see the shine. You can see that coming back up towards the camera. Of course, I can bend it. It's already been drawn into a wire. We could take a hammer and hammer this piece of wire and it would get flatter. This would be a piece of wire that could be found inside the walls to conduct electricity. Really nice pans to be cooking on at home would be made out of copper as well. And then where is this on the periodic table? Everything left of the stairs except for hydrogen. And then down here, the lanthanide and actinide series are also metals. Moving forward, we're going to talk about nonmetals, which are the exact opposite of metals. And they're going to be found on the right-hand side of the stair-step line. So that's going to be these atoms over here. And again, the word nonmetals can help you find these. So nonmetals are the exact opposite. They're poor conductors. They're dull, which they're not shiny. They aren't malleable, so that would be called brittle. They can break into pieces really easily. They're not going to be able to be drawn into wires. They come in all different states of matter. We have some solids, some liquids, some gas. Most of these are gases, though, because we have the noble gases as part of the nonmetals. They're going to tend to gain electrons in a reaction type setting. Do you want to show you a nonmetal? So this is sulfur. Sulfur is a one way it can come as a yellow powder. So notice that it's not shiny here. Since it's powderized, that's talking about the fact that it's brittle. This wouldn't have any use for making wires or making pans, etc. We already talked about where we can find those on the periodic table. Then the last main grouping of atoms that I'd like to talk about would be the metalloids. And those are going to be found along the stair-step line. There are 6 of them that you need to know for our class. You're going to start counting on the right-hand side. Start at boron. Count 4 down on the right-hand side. Boron, silicon, arsenic, tellurium. Go directly across to antimony, and then germanium. Now the atoms that are on the left-hand side of the stairs, since they're on the metal side, are going to be more metallic in character. Those that are on the right-hand side are going to be more non-metallic in character in general. An example of this would be, this is antimony. You can see that it's lustrous, shiny. If you were to put a conductivity tester on there, you're going to find that it does conduct some electricity. However, it's quite brittle. This is going to shatter into a million pieces if you were to hit it with a hammer. So the properties of the metalloids, also known as semimetals, would be a combination of both metals and nonmetals, and you can predict those properties mainly based on where they are relative to that stair-step line. So again, if we're on the left side of the stair-step line, should be more metallic. On the right-hand side, should be more non-metallic in nature. And you can see the list of those 6 that you do need to know. The one other thing I'd like to show you about the periodic table that's useful to us is how we can use how the square represents the state of matter. So we have, just on the nonmetal side alone, I can show you 3 different ways that the atoms are shown. This is a filled in letter, so this is going to be solid. Solidly filled in equals solid state of matter. We have bubble letters. If you're making a bubble out of your gum, you're filling that bubble with a gas. So bubble letters are going to be liquid. And then finally, there are 2 atoms, bromine and over here mercury. They look like they're bubble letters, but they're also leaning to the side. So bromine and mercury have leaning letters, which would be, italicized letters. But we're going to say leaning letters liquid to help you with a mnemonic. Leaning letters liquid for bromine and mercury. Those are the only two room temperature liquids that are elements. So that's the basics of the periodic table. Remember, you need to know horizontal and vertical arrangements. You need to know where metals and nonmetals are. You should be able to tell me the 6 metalloids, and then also use the periodic table to figure out solid, liquid, gas.